Hello students, it's Mr. Allen here. Today we are going to continue looking at chapter 1. We're looking at section 1.5, exploring angles. Our objective today is to identify special angle pairs and use their relationships to find angle measures. So our first two terms are adjacent angles and vertical angles. Adjacent angles, the word adjacent means next to or besides. So adjacent angles is just two angles that are next to each other. Now, technically, the definition is that it's two coplanar angles with a common side, a common vertex, and no common interior points. So, for example, you could see that angle 1 here and angle 2, those are called adjacent angles. Notice that they have a common side, that'd be this side right here. They have a common endpoint, which would be this endpoint right here. And they have no common interior points. So, for example, this point here is an angle 2, but it is not an angle 1. Angles 3 and 4 is another example of adjacent angles. Vertical angles. Vertical angles are two angles whose sides are opposite rays. So angle 1 and angle 3 are what we call vertical, and vertical is spelled like so. Vertical angles. Notice that these two angles, the ray that's opposite this ray is this ray. And the ray that's opposite this ray is that ray. So we can see that angle 1 and angle 2 are formed by opposite rays. Our next two definitions are complementary and supplementary angles. Complementary angles are two angles who have, when you add, they're adjacent. First of all, I should mention that. They are adjacent. Actually, I take that back. They don't have to be adjacent. Most of the time, they are adjacent. Complementary angles are two angles whose sum is 90 degrees. So 90 degrees is the key. So for example, this means it's a right angle, which means it measures 90 degrees. We learned that in our last lesson. So we would say that angle 1 is the complement of angle 2. So those two angles added together give you 90 degrees. Here's an example of two angles that are not adjacent, that are complementary. Notice this angle is 47, this angle is 43. 47 plus 43 is equal to 90. Supplementary, same thing, except instead of adding up to 90, the magic number here is 180 degrees. So for example, angle 3 and angle 4 are what we call supplementary angles. Or this angle B and this angle C are supplementary because when you take 137 plus 43, you will get 180 degrees. A nice way to remember the two, or to distinguish between these two, is I know that C comes before S in the alphabet, so complementary goes with the smaller number. All right, so let's see if we can identify some of these things on some true-false statements. It says, use the diagram to determine if each statement is true. So we got a colorful little diagram here. It says A, angle AOC, or I'm sorry, angle AOB, that's this guy, and angle BOD, that's this guy here. Are those guys adjacent? Well, let's see here. Do they have a common side? Yeah, they do. They got this side here. Do they have a common endpoint? They do. And they don't have any points in common in terms of the interior. So I would say this statement is true. Okay, let's look at the next one. I'm going to erase everything on there. Angle BOC, and angle FOE. That's this guy here. Angle BOC and angle FOE. Those are those two angles there. Are they vertical? Okay. Well, vertical angles, if we go back to the definition, vertical angles are two angles whose sides are opposite rays. Well, let's see here. The opposite ray of this side is this side, so those are opposite rays. But what about this one? Is this ray, this side, opposite this one? Nope. So this one's false. Oops, I erased my true on the first one. All right, let's go ahead and look at our last problem here. Erase what we got so far. Angle DOC, that's this guy, and angle COB. COB, that's this guy here. Are they supplementary? Supplementary. Okay, supplementary means they have to add up to 180. Well, 40 plus 50, that's not 180, that's only 90 degrees. So that's not true. In fact, what would we call those two angles that add up to 90? They're not supplementary. I wonder what the word is to be used for that. Okay, practice problem number 2. It says, given that angle A and angle B are supplementary angles, furthermore, it is given that the measure of angle A is 2x plus 3 and the measure of angle B is x minus 6. Determine the value of x. So we could draw a picture if we wanted to, and I might do that in a minute, but I'm not going to draw a picture right now because the important thing is this, is I know that they're supplementary. What does that mean? Well, if they're supplementary, then that means the measure of angle A plus the measure of angle B has to be 180. And now I can just substitute in. Well, what is the measure of angle A? It's right there, 2x plus 3. What's the measure of angle B? That's right there. It's x minus 6. It has to equal 180. So again, we need to solve this equation. So what's 2x plus x? That'd be 3x. What's 3 minus 6? That'd be negative 3. It's 180. So we're going to plus 3. We're going to plus 3. So we're going to get 3x equals 183. And now I got to divide both sides by 3. So let's see here. 183 divided by 3. So that'd be 6. So that's 18. 0 and then 3. So that's 1. So it's 61. So x is 61. When x is 61, then this is a true statement. And the key point here is I use the fact that these two angles were supplementary. I knew they had to add up to 180. All right, practice problem number 3. Determine the value of x for the measure of each, and the measures of each angle. Okay. We can do this one. This one, they gave me a picture. Oh, I think this little box tells me that this is a right angle. And if that's a right angle, I know it measures 90 degrees because that's the definition. And these two angles are going to be complementary, aren't they? Since they add up to 90 degrees. So this is what I got to know. I need to know that these two angles have to add up to 90. In other words, x plus 4 plus 3x plus 2 has to equal 90. All right, so we're going to solve this equation, very similar to what we did on the last one. X plus 3x is 4x. 4 plus 2 is 6. Now we're going to subtract 6 on both sides. It's 84. Now we're going to divide by 4, and that's also going to coincidentally be 21. That's what we got in the last one too, wasn't it? Oh no, we got 61. Okay, that would have been interesting. Okay, so now let's go ahead and go from there. So now we know what x is, so that's that part. Now it says we have to find the measure of each angle. So let's do this one here. So what is x plus 4? Well, x is 21 plus 4, so it looks like it's 25. So this angle is 25 degrees. And then that one there is going to be 3 times 21 plus 2. So that's going to give me 63 plus 2, which is 65. So this one's 65. So this guy right here. So x is 21, and the small angle is 20. The smaller angle is 25, and the bigger one is 65. Okay, and Now, I'm kind of covering this up, but I put a star next to this one. This is probably the most important slide for you to know. It's a postulate. Remember, postulates are statements we assume to be true. Here's what the postulate says. If two angles form a linear pair, then they are supplementary. What is a linear pair? Well, a linear pair is just two angles that form a line. So for example, I'm going to label this angle 1 and angle 2. Do you see angle 1 and angle 2? Would you agree that angle 1 and angle 2 form a line? Well, that's what we call a linear pair. If they are a linear pair, they are supplementary. If they're supplementary, that means they add up to 180 degrees. That's what this postulate's saying. A linear pair form a straight angle, if you will. All right, so let's look at this example here. It says use the linear pair postulate to determine the value of x. Okay, so we've got a line here. So it looks like these two angles are a linear pair. Got a linear pair. That's good. Check. If they're a linear pair, what can we conclude? Well, if they are a linear pair, then we know they are supplementary, because that's what the postulate says. If they are supplementary, what can we conclude? They add up to 180 degrees. So to solve this problem, I need to say that 93 plus 3x plus 18 equals 180. And again, there's kind of a lot going on here, so I apologize if this is a little overwhelming. But the reason I can do this step here is because of segment addition postulate, right? Segment addition postulate, which was in a previous lesson. So I forgot to put addition. Segment addition postulate, that's what allows us to say that this angle plus this angle is the whole angle. Okay, that was our previous lesson, set lesson 1-4. I need to solve this. Okay, we got to solve this. So let's go ahead and do that now. So we've got 3x is just 3x, but I can take 93 plus 18, and I'm just going to use my calculator here to make sure I don't make a mistake. That's going to be 111. Now I need to subtract 111 from both sides. Again, I'm going to use my calculator here just to speed this up. So we get 3x is equal to 69. And now we just need to divide by 3. 69 divided by 3 is 23. So the value of x for this problem is 23. This final slide is just a summary of some of the things that we've done and maybe some things that we haven't talked about. Basically, what you need to know is that there's certain times that you can use a picture to assume things, and certain things you cannot assume just based on picture. For example, you can assume in a diagram that angles are adjacent, that they're next to each other. You can assume if angles are supplementary and adjacent. And you can also assume if they're vertical by just looking at a picture. Where you got to be very careful, so I'm going to put this in red and put a star next to this. In a picture, you cannot assume just by looking at the diagram that angles or segments are congruent. You can't just look at them and say, oh, they're the same. You cannot say they measure the same. You cannot just look at a picture and say it's a right angle. So if I draw this angle right here, is that a right angle? You do not know. The only way you can know from a picture if it's a right angle is if I add this little symbol right here. And then finally, if they're complementary. That'll do it for that lesson. So I'll stop it there.